Here we're going to look at two other methods of factoring. One is with our trinomials. We're going to look at the perfect square trinomials, how we can factor those. And then secondly, we'll look at some binomials, and we'll look at the difference of squares and how to factor those. Now what a perfect square trinomial is it's of the form a plus b squared. And as you did in the past, when you simplified a plus b squared, remember a plus b squared is a plus b times a plus b. We're multiplying it with itself. And as you distribute this, a times a is the a squared. And then you'll have ab times, or a times b plus a times b. There's two of them, so it'll be 2ab. And then you'll have your b squared. So if the trinomial is of this form, a squared plus 2ab plus b squared, then you can factor as a plus b squared. And then also when you have a minus b squared, again that would be a squared minus the 2ab plus b squared. And we'll learn a way in which we can factor these. So like for an example, if you have x plus 3 squared, you'll have, again, this is x plus 3 times x plus 3. X times x is x squared. You'll have a 3x and another 3x. There's two of them. That's why there's a 2ab in here. So that'd be 6x, and then 3 times 3 is 3 squared. Then we're going to take a look at the difference of squares. And for the difference of squares, again, this is a binomial, two terms. It has to be a minus in the middle. If you have an a squared minus b squared, this could be simply be factored as a plus b times a minus b. Because, again, if I distribute this, a times a is a squared. A times negative b is negative ab. And then b times a is a positive ab. These two will cancel each other out. And then you'll have a minus b squared. So that's how we get a squared minus b squared. You'll just take the difference of those two binomials. So let's go ahead and factor the following. In our first one here, we have this x squared plus 16x plus 64. This is a trinomial. First off, again, take a look at the GCF. The GCF of x squared, 16x, and 64 is just 1, so we can't factor it any further. Now, in our previous lectures, since this is a coefficient of 1 with this, I can take the 64. There are two numbers I'll multiply up to 64 and add up to 16. Well, we know 8 times 8 is 64, and that adds up to 16. So this can be multiplied as x plus 8 times x plus 8. And since it's itself, we can just square it. So this is just x plus 8 squared. Now again, you can use the other techniques to work with this, or you can use a simpler technique. And this is what you can do. If you take the square root of this coefficient, square root of 1 is 1, and the square root of 64 is 8. If you take the twice of 8 times 1, so 2 times 1 times 8, 16, and if that's the middle term, you know this will be a perfect square. If this is a positive term in between, it'll be a plus b squared. If this is a negative term in between, it'll be a minus b squared. But again, this will have to be a positive x squared and a positive 64. You can take the square root of them and double it. If it's the middle, then it'll be a perfect square. Okay, we'll look at some other examples later on. As for number 2, we have y squared minus 36. Now this is not a trinomial, so we can't use the other methods. This is a binomial, just two terms. And if I look at this, this is the same as y squared minus 6 squared. See, these are the difference of squares. So like we did earlier, we can factor this as x minus 6, or y, shall I say, y minus 6 times y plus 6. Again, if I check this out, y times y is y squared. 6y minus 6y cancels each other out. A negative 6 and a positive 6. And when multiply, it becomes negative 36. So that's how that can be factored. Let's try number 3 and number 4. For number 3, we have a trinomial once again here. And the first thing I would do is looking for the GCF of these three terms. Since that's a 1, we know there is no other GCF other than 1 that will work with this. And so what I'll do real quick is I'll take the square root. I see 49 is a square. Square root of 49 is 7. Square root of a squared is a. The square root of 1 is 1. And I'll multiply these two. 7 times 1 is 7. And if I double, that's 14a. Oh, that's the middle term, right? So therefore we know this would be a perfect square. So just by looking at it, if I grab the 7a and the 1 and bring them down, this would be squared. Now the question is, this would be 7a plus 1 or 7a minus 1. And like I was saying earlier, if you see this minus in front of the b term, as long as the other two are positive, this would be a 7 minus 1 squared. And that's a quick way to factor this. Again, you can use that AC method. 49 times 1 is 49. What two numbers multiply up to 49 add up to negative 14? Those are both negative 7s. And you continue that way. That's a longer process. I'm showing you a quicker way in which you can do this just by analyzing our polynomial. I mean, again, I can check my work here if we want. A little check. What is 7a minus 1 times 7a minus 1? And as we factor this, because that's what squared means, right? Multiply it with itself. 7a times 7a is 49a squared, minus 7a minus another 7a, then plus 1. These will become negative 14a. And that's exactly what we started with, so we know this is our correct answer with it. How about number 4? For number 4, first I want to look at the GCF of 9y squared plus 30y plus 25. Let's see, 3 goes into 9, 3 goes into 30, but it doesn't go into 25, so this is broken down as far as possible. Let me try real quick. Square root of 9 is 3, square root of y squared is y, square root of 25 is 5. If I multiply these two together, it's 15. And if I double it, that's 30y, and that's what the middle is. And this is where we can check and see if this is a perfect square trinomial. And here it is, since all this worked with all of it. So as I know, the square root of 9y squared is 3y. Square root of 25 is 5. Since this middle term was a positive number, we know this will be a plus, and that is squared. And that's how that works. How about x squared minus 1? Can you factor this one? Now, this is not a trinomial, right? This is a binomial, just two terms. And so this is a difference. So is this a difference of squares? And we see the square root of x is x, and the square root of 1 is 1. So therefore, we'll know this will be x minus 1 times x plus 1. That's a really simple factoring technique. If it's a binomial, there's a minus in between. They're both squares. And it'll be x, the first one minus the second one, and the first one plus the second one, because the middle terms will cancel out when distributed. How about number 6? C squared plus 4. Again, this is a binomial. Oh, these are squares. This is c squared plus 2 squared. My question is, can you factor this x plus 2, or c, shall I say, since our variable c, times c minus 2? Will that work? And if I look at this, this would become c squared minus 2c plus 2c minus 4. Oh good, the middle terms cancel out, we don't have any c's. But the only thing is this is a minus 4, not a plus 4. And then others say well, see, c squared plus 4, well, that would be the same as c plus 2 times c plus 2, huh? Or maybe that perfect square. But as you continue this becomes c squared plus 4c, because 2c plus 2c is 4c, plus 4. Oh, good, you have that c squared plus 4, but now you have that 4c in the middle. It's not what we started off with. Well, let me just cut to the chase here. When I work with this, whenever we have two squares and there's an addition in between, for us here in Math 89, this is a prime factorization. This cannot be factored any further. Okay, so a little note, if you have a sum of squares cannot be factored any further. Or it can't be factored in this class. How about number 7? 7 is 5x squared minus 80. Okay, so this is a binomial again. And this doesn't look like a difference of squares, because I know like 5 is not something squared, or 80 is not something squared. But there's one step I missed before this, and that's to do the GCF. Like always, you should factor out the GCF. So if I look at this, I see 5 is a factor of both of these. 5 goes into 80 16 times. And 16 is 4 times 4. Oh, so this is difference of squares. So it's x minus 4 times x plus 4. And don't forget to bring down this 5. And therefore that's our answer. Number 8. What if you have x to the 4th minus 81? Now, we haven't worked with fourths, but isn't x to the 4th the same thing as x squared squared? So this is a squared, and 81, that's just 9 squared. Oh, so this is a difference of 2 squares, and so this is the same as x squared minus 9 times x squared plus 9. Because x squared times x squared is x to the 4th. X squared times a positive 9 is 9x squared. Minus 9x squared, those two will cancel out, and negative 9 times 9 is a negative 81. Wonderful. But is this factored all the way? Can I factor it any further? And the answer is yes, because look, isn't this another difference of squares? Isn't this 9 the same thing as 3 squared? Therefore, we can say, look, this is x minus 3 times x plus 3. And my next question is, well, can you factor this x squared plus 9 anymore? And the main thing is, look, this is a sum of squares, and you can't factor sum of squares any further. So therefore, we'll just bring this x squared plus 9 down below. And this is our complete factorization of the x to the 4th minus 81. So a little note on this, if you have a difference of squares, just take the first square minus the second, and times the first one plus the second. Those middle two terms will cancel out if you're going to check your work and distribute all those terms again. Sums of squares cannot be factored at all. Hope all is going well. Have a good day.